building a part that actually works is actually pretty difficult. So I got a great example here. I have a hinge. This would be attached to some part, and then I have the actual tab that goes up and down, and then I have my shaft that would slide in there. So the first thing that you need to think about is the fit. Force fit, snug fit, or loose fit. So with my shaft, if I have my piece up here, when I slide it in, I want this part to be nice and tight, but I want this one to be loose so the tab will actually move up and down. And so for this part, I would use the force fit right here, which I would chamfer the ends right here, so I'd be able to nudge that shaft in there. And then I would want a loose fit right here, so then the tab would actually be able to move up and down. And depending on what you want, you might even want it snug, because if you want to be able to move it down, but you want it to stay, you want a snug fit. And that's all about tolerances, and I'm getting there. So materials, this is a big part. So tolerancing is all about materials. If you're a materials engineer, you love this kind of stuff. So metals will fluctuate with heat. Everything fluctuates with heat, but it all fluctuate differently. You can either calculate it or look at the spreadsheet that the manufacturer gives you. Say, for example, it fluctuates at 0.1 plus or minus 10 degrees, something like that. So depending on what it is, it's going to fluctuate in different sizes, and you need to be careful with that, because even though you build it so it fits right, it might get too hot, and this part's going to absorb more heat and it's going to expand, and then the shaft is going to slide out. So you need to be really careful about that. So that kind of brings us into our next part, building it. So when you're building it, you need to think about what machines are you using. Are you hand building it? Are you designing it with a 3D printer? Are you doing injection molding? All of these have way different tolerances, because if you're hand designing it, you need a lot larger tolerances. If you were doing it with a 3D printer, you're going to have a lot smaller tolerances, or injection molding, all this kind of stuff. So that's kind of goes into your standard deviation. What is the change, the accuracy or the precision of that machine? So when you're building it, you already need to know how you're going to build it, because what you're building it with, it will fluctuate in the sizes, because if one size is too large, that piece is not going to be able to fit in there anymore. And the last part is manufacturing. You need to think about manufacturing, because you could build a one-off piece, but if you need to build 10,000, 10 million parts of this, it's not going to work. So it might be a lot easier to build a square hinge instead of a circular hinge, because your materials come in a square piece. So you need to think about that when you're designing that as well. And the complexity of it, if you can make it a little bit more simple, if this part can be a little bit easier to attach, whatever it is, the complexity of it is going to increase your price. And always with engineers, tolerancing, all that fun stuff, the more complex, the higher the price, and no one really likes that. So resources, what kind of resources do you have around? This falls back to your materials, what kind of materials and machine, software, different types of slicers if you're doing 3D printing. So all these things, manufacturing, building it, and materials, and your fit, all come into play when you're building and designing something as simple as a hinge. So I hope that helps, and good luck to you. Thank you, and I hope you subscribe, like, comment, everything. Thank you very much.